Hello, this is Mr. Huff, and let's take a look at a few things about coefficient of drag and coefficient of lift. So, first thing I want to do is point out that this is a rho. It's a Greek letter and it stands for density, not to be confused with the letter P that we use for pressure. Rho and P look similar, but the rho means density. So in these calculations, you'll be seeing the density, not the pressure. Okay. Another thing you'll have to do is you will have to convert some kilograms to weights. So in order to do that, you're going to take this formula: weight is mass times the acceleration due to gravity, which is 9.81 meters per second squared. So what you're going to do is take your kilograms, multiply times 9.81, and now you have a weight in newtons. Let's take a look at these two formulas. They look real similar. The only difference is one is looking at lift and the other one is looking at drag. So lift goes up and down and drag goes from front to back. Okay, so the coefficient of lift is the ratio of 2 times the lift divided by the area of the wing times the density of the air times the velocity the wing is moving squared. And the coefficient of drag is similar, except in this case we're looking at the drag, not the lift. All right. To rearrange this to solve for lift, we are going to multiply both sides by this expression and divide by 2 and end up with this calculation. In the same way, we can use this formula to solve for drag, rearranging exactly the same way. If we want to calculate the velocity, we need to look at multiplying both sides by velocity squared to get it out of the denominator and divide both sides by the coefficient of lift or the coefficient of drag, and you end up with this formula down here. My advice is to solve this way and then take the square root of your answer to get the final velocity. Don't forget to take the square root of your answer if you're solving for velocity. All right. Let's take a look at a totally made up sample problem. So we have a lift of 5,000 or 50,000 newtons. We have an area of 70 square meters. We have an air density, rho, notice that is not a P, of 0.97 kilograms per cubic meter, and then a velocity of 95 meters per second. I just totally made these up on the spot. Okay, we're solving for the coefficient of lift. And this is our formula. The coefficient of lift is equal to 2L over area times rho times v squared. I replace these terms with these numbers, so this is what I'm putting in my calculator. And when I get done, I get this. The coefficient of lift is 0.1631. Notice this ratio, all the units cancel out, so there's no unit for coefficient of lift nor coefficient of drag. And then the other thing I want to point out is because it's random numbers, this is a really unreasonably low coefficient of lift. It's normally like 1 to 1.5. It's typical for most planes. So, but this is a walkthrough of how to show your work using guess. Okay, so you're going to give me the givens, the unknown, your equation, and then show me the substitution and your answer with appropriate units, unless there are no units, which is what we see in this case. All right, that's enough for getting you through these calculations. Thanks for watching.